presentation, a few minutes, about their product and their company and themselves. And then we'll just sort of open up for questions from the audience. We can talk about whatever you want. It can be technical, it can be non-technical, business cases, whatever. We're open for anything. So I'll just kind of introduce you guys real quick. So first, from IBM, we have Jeff Wells. We have lots of Jeffs. So he'll be talking about Hyperledger. Next, from Curvegrid, we have William and Jeff. Stand up, guys. Yeah, so we have two of them. That's good. Thank you. And finally, from R3, they're going to be talking about Ethereum. From R3, he's going to be talking about Corda. We have Munitoshi Yamada. Okay, so we're going to start off with Jeff number 1. Oh, we're going to start off with Jeff number 2 and William. Okay. From Curvegrid, they're going to talk about a little bit general stuff about blockchain, and then also talk about their company. There you go.
Thank you.
Got a quick question first.
Yep.
The slides and whatnot, will these be published later on the site?
You guys want them to be public?
Yes.
Yes.
Okay.
Okay, well, I'm back in this presentation. Now, how many people here have heard of Bitcoin? Okay, good. What about Ethereum? Okay, perfect. So this is an introduction to Ethereum. My name's Jeff, and my co-founder William is here as well. We started our company in May this year to build an application server for the blockchain. We're focusing on Ethereum to start. So blockchain is a decentralized ledger, and here you can see an example of a double-entry bookkeeping ledger. It's fairly standard. Alice is paying Bob 2,000 Ether, and Ether is the currency of Ethereum. In Ethereum, transactions are an atomic entry on the ledger, and transactions are grouped together into blocks. Blocks are appended to the ledger, and they are immutable. Account names are not actually names, they're actually represented by numbers, so it's like a bank account number, and these are impossibly large numbers. There's more account numbers in the Ethereum namespace than atoms in the universe. So we're never going to run out. Some transactions can also include computer code. So in this case, we now have Alice sending Bob 2,000 Ether and also calling a computer function called remit. But if Alice is calling a computer function called remit on Bob, who or what is Bob, or what does Bob represent? Well, Bob's account number actually represents a computer program that runs on the Ethereum blockchain. And so this program was uploaded in an earlier block and includes this function called remit, and it's actually running on the blockchain itself. So computer programs on the blockchain, and this is the fundamental difference between Ethereum and most of the blockchains that came before it, including Bitcoin, that you can run any kind of computer program on the blockchain. So it allows you to do much more complex things. These are also known as smart contracts, which you may have heard of. They can hold and dispense their own value, or their own ether, and they are governed entirely by the rules of their computer code. They're immutable, and they cost gas, or a transaction fee, to invoke. And the concept of a limited amount of gas per transaction prevents runaway computer programs from running amok. If we take one step up from that, from the smart contract, we have the concept of a DApp, or decentralized app. You may have heard this as well. Essentially, it's the combination of a traditional piece of software and a smart contract. Typically, it's a web application combined with a smart contract running on the blockchain. And this is where things start to get really interesting with Ethereum, because we can do things like document or asset attestation. So this digital asset existed at a given point in time, or this contract was signed at a given point in time by a given person. It has applications to KYC and AML, and also securities, not just in the sense of tracking securities on a ledger, but actually implementing the security itself on the blockchain, because we have an arbitrary computer program that can hold and dispense its own value. If we take one step out and we look at what Ethereum looks like in a bigger picture, Ethereum is a collection of nodes. The Ethereum network is a collection of nodes, and each node has a copy of the ledger, and the nodes communicate over the internet in a peer-to-peer sense. So there's no centralized authority kind of arbitrating The nodes arbitrate amongst themselves. But what prevents a node from inserting a bad transaction into the ledger? For example, spending the same piece of ether twice. And this is where kind of the real meat of safeguarding the public Ethereum blockchain comes from, and what separates a public blockchain like Bitcoin or Ethereum from the private distributed ledger technologies that you're going to hear about from some of the other panelists. In the case of Ethereum, there are special nodes called mining nodes, and these race against each other to solve a very complex mathematical problem that takes a lot of computing power and a lot of time to solve. The winning mining node that solves this problem gets a quantity of ether. This is how the money supply increases, as well as all of the gas or transaction fees that were in that block. You can think of this as work. We're doing work, we're spending electricity, we're spending CPU cycles to do this work, and that's also known as proof of work. So if we have a malicious actor that comes in and wants to insert a bad transaction, in order to do so, because each of these blocks and their work sort of forms this immutable chain, they would have to do all of the work that had been done before them, right? And that is blocks times work times time, and 8 years of Bitcoin being in production has proven that this is just not possible. So to take a look at some of the people and organizations and technologies that are involved with Ethereum, this is if you want to do a little bit more reading. Vitalik Buterin, you've probably read about him. He originated the idea. He wrote the original white paper, and he's still the lead developer. Dr. Gavin Wood wrote another document called the Ethereum Yellow Paper, which is essentially an academic document that describes in great detail how Ethereum works. There's Joseph Lubin, who founded an organization called ConsenSys, and there are other co-founders and certainly other significant people involved in Ethereum, and this is just a sampling. If you're looking to use Ethereum in Japan, there's a number of exchanges which you can furikomi fiat currency to and receive Ethereum. You would need to use Ethereum client software, which are listed on the slide. And then there's also other technologies which are kind of integral or being built on top of Ethereum that form kind of the core idea of what it's used for. One of them is the Ethereum naming service, which is kind of like DNS for Ethereum. And then the other concept is and I use this loosely in terms of technology or concept, is the concept of the initial coin offering, or ICO. So how many people here have heard of an ICO? Okay. Essentially this is raising money on the blockchain via crowd sale of tokens, and there's a nuance to this in that the tokens don't exist on the blockchain on their own. They're essentially recorded inside of a smart contract that's being placed on the Ethereum blockchain. I think we're all aware of what the kind of momentum behind this. I wanted to point out that in June and July of this year, there was more money raised in ICOs globally by startups than all of the venture capital money raised by startups in those months. If you weren't aware, ICOs or token sales are possibly subject to securities regulations. The FSA in Japan has not publicly weighed in on it yet, as far as I'm aware, but certainly the SEC in the United States has published some guidance recently, which might be of interest. Here's a sense of kind of the scale of these cryptographic tokens in terms of how much is out there and their trading activity, and these are trading actively on cryptographic exchanges. I'm sure most of you are aware of the kind of historical price of Ethereum, but it started all the way back in July 2015 at pennies to the ether, and when the ICO boom started in March of this year, that was sort of the last time we saw it below $13, and now it's up over 300 and hit a peak of more than 400. Thank you. That's my presentation. Again, we're building an application server on the blockchain, and also available and helping companies do contract software development work to work with blockchain technologies. Thank you.
All right. Great. So that was Ethereum. Now, over to Jeff number 2, who's going to talk about IBM Hyperledger.
Thank you. I guess I have to switch the presentation. Could I ask you to do me a favor and switch to my presentation while
Hey, where's Norbert?
Thank you. Sorry, I'm not an Mac expert. I use PC. But I do use an iPad, so yes, thank you. So I'm going to start and talk about this iPad, actually. Even though I don't use Macs, I use a PC. But, so the previous Jeff was talking about public blockchain, which is focused a lot around coins and currency, right? But I'm a business development executive from IBM, so I focus on how can we use blockchain to build solutions for businesses. So let me use this iPad as an example. So to make this iPad, we've got a microprocessor in here from Taiwan Semiconductor. We've got a display screen here from probably LG in Korea. We've got a metal case that was maybe manufactured by a company in China. And then all of these parts go to Honhai factory in China and get assembled into this iPad. And then it gets shipped to Apple or maybe direct to me, the customer, right? So we've got all these different companies involved, and I obviously simplified it in order to produce this iPad. Okay, so what's that got to do with blockchain? Well, actually there's more players involved in that too, right? You've got shipping companies. So Taiwan Semiconductor has to ship the processor to Honhai in China, right? So you've got a shipping company involved. And then Apple's got to pay everybody. So now you've got banks involved. Maybe you have more than one bank involved. Because in different companies, you have to use different banks. In Korea, you use one bank. In China, you use a different bank. In Taiwan, you use another bank. So now you've got what's the total? Around 10 companies I've talked about so far involved in producing this iPad. And I'm just getting started. There's obviously more companies involved in that to make this iPad, right? So you've got all these companies, and what happens if something goes wrong? What if Honhai in China says, hey Apple, you didn't pay me enough money. I made 1 million iPads, but you only paid me for 900,000. Well, now you've got to go and track all that down, right? Well, did Honhai get delivered enough processors? Were there some screens missing? Is that why they didn't make 1 million? Did Apple just make a mistake and they should have only paid for 900,000? They got a problem with computers, right? So now you can imagine when you have a problem, how are you going to track all that down? You've got all these companies involved. That's a very complex process. Well, blockchain is a solution for that. So now what if all of these companies subscribe to a private blockchain, not public? They want to be private because you don't want to share this information with the individual consumer, right? You don't want them to have access to this. You want to be private. So now you create a private blockchain and you store all the information about all of these transactions in the private blockchain. So when Taiwan Semiconductor ships a chip to Honhai, that's recorded in the blockchain as a transaction. On this day, I used this shipper, let's say FedEx, right, to ship this chip to Honhai in China. Right? So this is all recorded in the blockchain. And each time there's a transaction that takes place, each time there's a movement between the companies, that's recorded in the blockchain. So now if there's ever a problem, you want to do accounting around this, the regulator wants to go in and inspect because they think some fraud has taken place, it's much easier to do. It's all right there in the blockchain. And one of the characteristics of blockchain is that every company has a copy of it, and every company agrees that we all have the same copy. So it's very, very easy. Now that there's trust around this ledger, and everybody can agree that, oh yeah, when we track down why did Apple only pay for 900,000 instead of 1 million, everybody has the same information. Everybody can agree on where the problem was, and it's easy to track that down. So that's just one example of why you want to use a public blockchain. And as you can imagine, if you take that now to trading stocks, right? You've got a stock exchange, you've got a buyer and a seller, you've got a settlement company for those of you familiar with stocks. It gets more complex than that. You've got how many hundreds of thousands or millions of transactions a day. And every day on the stock exchange, let's say 5% of them is a discrepancy, right? That's a lot of work effort going on right now. If you have a blockchain, actually you could even write a computer program to go through the blockchain and find out where the error was, report it to everybody. And you can resolve those things really quickly and save a lot of time. Instead of taking 3 days to figure it out, it might take you only 1 hour. And you can quickly settle the transaction in a way that everybody can quickly agree. So that's the value, an example of the value of public blockchains. And IBM has contributed code to and is a member of one particular, I said public blockchains, I'm going to go private blockchain. One particular private blockchain called Hyperledger. And Hyperledger is open source. And it was created by the Linux Open Software Foundation. It is the fastest growing project ever in the history of the Linux Foundation. It was formally announced in December of 2015. There's around 150 members, and I'll show you who those are in a moment. And IBM is one of the premier members of it, and contributed a lot of code for free to Hyperledger. So here's a list of the roughly 150 members. You can see there's somewhere around 20 premier members. And what's the difference between premier, general, and associate member? It has to do with how much you've contributed to the project. So the premier members in general have contributed the most to the project, and IBM is one of those members. But you can see there's a lot of companies involved, and you can see a lot of kind of famous names there: Accenture, American Express, Cisco, Airbus, Deloitte. There's a lot of well-known companies involved in the Hyperledger version of blockchain. And we recently had a big milestone in July of 2017, 2 months ago. Version 1.0 was released, and now there are 159 developers in 27 different organizations, all continuing to enhance the product. So what does IBM do, and what does IBM have to do with Hyperledger? In addition to designing solutions using Hyperledger, actually IBM has created an entire development environment around it. Hyperledger itself has something called a composer, which allows you to minimize the amount of code you have to write in order to develop a blockchain application. It's something like, for those of you who do software development, like an integrated development environment, like Eclipse, for example, that's blockchain and Hyperledger specific. So IBM has added on top of this, because we have something called Bluemix, which is an integrated development environment. It has like almost any database you can think of, there's an icon in there for it. For most of the industry platforms, for example, in banking or insurance, there's some core industry platforms, there's an icon for those. For most middleware, there's an icon for those. For almost every programming language, Java, C, C++, there's an icon for those. And then there's an icon in there for Hyperledger. And what that means is just by dragging icons together, you can instantly build a development environment on a cloud, have it up in a matter of seconds, assuming you don't need a lot of servers. Just click a bunch of icons on a screen, and boom, you can have a development environment with all of these components in there, and they can all be integrated together easily within this development environment. And so that's the value that IBM is trying to add on top of what exists already in the Hyperledger framework. So if one of my customers, let's say a major insurance company, wants to build a blockchain application, they can do that much easier by clicking and dragging on a bunch of icons that actually having to write a lot of code. Of course, in many cases, you'll still have to write some code, but it drastically minimizes the amount of code that you would have to write. So what's IBM doing with blockchain or Hyperledger specifically in the world? We're involved in a lot of different industries. You can see a wide range here from trade finance to insurance risk coverage, loyalty programs like point card programs, and food safety, supply. I talked about how to build an iPad, and that example I talked about was supply chain work. So do a lot of different things in a lot of different industries. And how do our clients get started with blockchain? Well, probably some of you attended the session 2 or 3 times ago where we talked about design thinking here. So we use a process called design thinking to come up with the idea, looking at who is the user, who is the customer for this solution, and how can we help them. And then we create an experiment for the application. We prototype it and actually try it. We can use that Bluemix environment I just told you about to build it very, very quickly. You can quickly try it within a matter of days or sometimes within the same day. And then that Bluemix environment allows you to integrate it with what we have today. It actually has an automatic API builder for those of you who code. And that makes it very easy to connect with our customers' existing applications. In a lot of cases, you can just drag and drop and go to create those connections instead of having to write code. And then, IBM is a 100-year-old technology company. Sometimes a lot of people think of us as this big mainframe company, right? Quite different from, I think, Curvegrid, who's a brand new startup, right? So people might be thinking, we're kind of old and stodgy. Guys with gray hair and suits and ties, right? But actually, IBM has totally transformed itself in the last 5 years, and around these types of technologies, we behave like a startup. So we use lean startup methodology, we use agile development, we have DevOps operations, we do everything on the cloud around these types of applications, etc. So we actually spend a lot of time transforming ourselves after the last 5 years and try to behave like a startup. And so when we actually build something, how long does it take to build? We usually take 2 days to figure out what it is we think would add value. And we take 3 days to actually prototype it and design it. And we actually build what's called a minimum viable product. So what is the smallest or easiest to build product we could create that would actually deliver some value to the audience? And that usually takes less than a week. And then once we've done that, we collect feedback on it, tweak it, enhance it until we're comfortable it's ready to be released on large scale, and then we release it at scale. The nice thing about the Bluemix environment is all of this work you do here to develop your prototype and your minimum viable product, it's very easy to scale because all you have to do is push a few buttons and you can go from 10 servers to 10,000 servers in 54 countries. So that's the value we try to bring to Hyperledger. Thank you.
All right. Thank you very much. And now we'll talk about R3 Corda, and we have Monique. I can't look at things, so, but I know you can.
All right, so hi everyone. I'm Mure from R3. I'm responsible for Japan operation, especially I'm a project manager, so I'm responsible for project management with Japanese clients. And I've been with R3 for just one year now. And when I joined R3, we have only 70 employees, and now we have over 140. So now it's double. So we are really growing rapidly. And so I'm gonna give you what is R3 and what is Corda, just briefly today. So for those who are not familiar with R3, so what is R3? So R3 is the world's largest distributed ledger consortium. So some people think of consortium as just a non-profit organization, but we are a company. So we are laser focused on commercialization of our product. So now we have over 100 financial institutions members, and working together to build what is called Corda. So Corda is our product, and so you can see here it's a distributed ledger. So what is distributed ledger? Why do we call ourselves a blockchain company? So that's because simply because we don't have block. So with Corda, we don't create a block. Block is a bunch of transactions, right? So, but we just deal transaction one by one. So we don't need block. So that's what we call ourselves distributed ledger technology company. Okay. So what we are doing is so we do a lot of things. We do projects, we do research, and of course we build Corda. So, but the ultimate goal is to build what is called R3net with Corda. So what is R3net? So R3net is a private network with financial institutions and other players. So you see on the left side that 3FI, FI means financial institutions. So R3net is a network, private network for financial institutions and corporates. So with in R3net, they can transact directly each other without any trusted third party. So we can, so in R3net, we are able to transact any type of transactions, like a fund transfer, OTC derivatives, trade finance. So Corda is just a middleware package software. So and on top of Corda, so we can build a bunch of applications. So like for example, if this financial institution and this financial institution wants to make a interest rate swap, then they can do it just between them, but they need interest rates to make interest rate swaps. So Oracle is a node who provides like external data like interest rate or foreign exchange rate or something like that. And so one of the characteristics in R3net is we assume regulators. So in R3net we don't share data like other blockchains. We just save data just between the parties involved in the transactions. But only regulator can see the the transaction, the whole transaction in R3net. And so notary is one of the nodes, but which provides kind of proof of work. So I don't want to detail today, but so the role of notary is like a proof of work in Bitcoin. Okay, so looking closer at one node, so it looks like this. So Corda is divided into two parts, like open source Corda and enterprise Corda. So the open source Corda has basic Corda components like state object, transactions, and others. And both is a storage and network map service is kind of function to transact other nodes. So you can use Corda open source for free. You can download from GitHub. So with Corda open source, you can build a proof of concept. But assuming production environment, we need more additional functionality like multi-threading or modular RDMS or SGX. So Corda Enterprise is not free, but it improves like integrity, securities for financial institution to use in a production environment. Like for example, so what is modular RDMS? So Corda open source supports H2 database. So H2 database is an open source database, but financial institution never use H2 database in a production environment because they cannot get support because it's open source. So if you want to use Corda in production environment, we need more trustable database like Oracle database or SQL database. So with this function, so you can use enterprise grade database. Okay. So these two layers are called what is called middleware, and on top of Corda, so you see several Corda. So Corda is an application which run on top of Corda. And R3 just built Corda, Corda open source and Corda enterprise, and we never built Corda because we want to make R3 nets vendor lock free. So we partner with software vendors or system integrator to build trade finance application or identity application and OTC derivative applications. So that's our strategy. Okay, so there are several characteristics which differentiates Corda from other platforms. But so to them, let me introduce just two things. That's one is data sharing model. So in blockchain world, we all share data to basically to have proof of concept. But in financial institutions, the financial institutions don't want to share data, right? So that's a requirement from financial institutions. Like, for example, so if I borrow 1 million yen from Jeff, and so then I don't want to tell anybody, right? I don't want to say just, hey, I borrowed 1 million yen, so something like that, right? So in financial institutions, so we don't want to share it. We don't want to make it confidential. So, but in blockchain, if you want to do proof of concept, you need all data, right? So with Corda, we just share data between parties, right? So that is called need-to-know basis data sharing model, and so we don't broadcast data. And the other feature is that regulatory requirements. So we build Corda from scratch, assuming regulators. So we are focused on financial institutions industry. So we need regulators involved in our network. So we implemented the requirements from regulators. So only regulators are able to see all transactions. So lastly, this is a roadmap. We are here, and we have two important milestones. So one is Corda open source version 1.0 release, which is scheduled by the end of this month. Okay, and another important milestone is Corda Enterprise version 1.0. This will be released by the end of this year. Okay, so that's all I have. Thank you.
If I could invite all of the panelists to have seats. Are we going to be right in front of the light? Alright, hey Norbert, how do I turn this off so that they're not directly in front of it? Yeah, really that way? Okay, that doesn't make any sense. Yeah, I don't, seriously? You don't know how to do it. Alright. Nobody?
Is a black screen available? I'm okay.
Like PowerPoint application and use Mac screen. like just click on the icon.
How about you try it? Thanks. Sorry for the technical difficulties. All right. Why don't I do that? Okay, so while he's fixing our problems, we're just going to kind of open the floor to questions. You can ask about anything you want. If you don't ask questions, I'm going to start asking questions, and nobody wants that. So you might want to start raising your hands. All right, we got one guy in the back. You want to start? You got to talk really loud.
Yeah, no problem. I can handle that. So I've been in the Bitcoin blockchain space for a whole bunch of years, and I guess real quickly, I'd be curious to see what each of you guys think. Like, what is the main value proposition of a blockchain? I would personally say the main value proposition of a blockchain, the main utility is censorship resistance. So I would say that Bitcoin currently is and probably will continue to be the most valuable blockchain there is. I see that in a similar way, like the internet was more valuable than a lot of private intranets. I'm just kind of curious to hear what your thoughts on that. Pretty broadly speaking, like Bitcoin versus private blockchains, and what's the value utility of a blockchain?
Okay, I think that's a pretty interesting question. It gets at the more basic question also about the difference between public and private blockchains, which is something that you heard from our speakers as well.
Right.
So maybe we can start with the public blockchain. You guys want to start over there?
Sure, I'll start. It's a very interesting question and observation, thanks. It's interesting that you mentioned censorship resistance, so, and made the parallel with the, when the internet came out. So it gives you a way to, it makes actions available to people in a way that things hadn't been done before. So the internet, let's say a killer application there is email, right? That's what got things started, and I think of the main thing that blockchain's initial utility for was the transfer of value. Now the internet isn't so much about, let's say, censorship resistance in the same way that with a blockchain, especially a public blockchain, a lot of it becomes quite transparent. The main features that you would get out of it, I think, are this being able to do things in a trustless manner. If I have an analogy, right, if I want to transfer, if I wanted to send you money right now, I almost, if we can't meet in person, I need the permission of a bank in a way to do that, right? Then I'll need to rely on the utility that the bank provides to make that transaction. Whereas the, Bitcoin blockchain, Ethereum blockchain is just out there. You can just do it. You don't need anybody's permission to do that. And there's a lot of anonymity there right now, but it's all traceable. And as regulation increases, it's going to be easier for governments, let's say, to associate these blockchain addresses with real people, and necessary for doing things like preventing money laundering, let's say. I don't know if that answers it very clearly. We go into a bunch of different topics, but
yeah, I guess if in a sentence, like, what is the value? So the value proposition of, say, Bitcoin is censorship resistance. What's the quick value proposition for a private blockchain versus a public blockchain?
Well, we could hand it over to Jeff number 2, or Monet. Do you want to take it?
Okay, well, let me try an analogy. Hopefully it'll work here. So I'm sure pretty much everybody's familiar with Facebook, right? So there's Facebook, where you can publish all kinds of things about yourself in public, right? And then Facebook also has Messenger, right? You can share messages with people individually. But one way I use Facebook Messenger is I create groups. Or for those of you who use Line, you probably create groups within Line as well, right? So for example, within my extended family, my parents, my sister, etc., we all have a group within Messenger. And we exchange information within that Messenger. So for example, we want to plan our Christmas trip. So we're all going to gather at my sister's house for Christmas. We'll exchange information in that private Messenger group about our Christmas trip, right? And we don't want to share that with anybody else. It's great to have there as a reference so we can all remember what we all said, what day we're supposed to arrive, who's coming in on what airport, how long we're going to be there, where we're going to stay, all that kind of stuff. It's a great reference for the whole family to have, right? Well, that's the same thing with the private blockchain, in the example I was giving, right? So you've got a network of companies all doing something together, and it's a great way for them to easily and quickly communicate, store as a reference what we all agree to, what we said we would do, and if we need to reference it, anybody can do that any time. We all agree that all that information is correct. We don't have to worry about trusting that information because we all agree. And if there's ever a problem, we can always reference it and quickly figure out what happened to our logistics for our trip, right? So that's the value, I think, is it's that easy reference. Now imagine I tried to arrange that trip with my family without Facebook Messenger. We're using phone and paper, and everybody's got their own piece of paper. They've written it down. They might have different information. Everybody might have different information on their paper, or not complete information on their paper. Right? It makes that whole process much more efficient and easy to reference at a moment's notice. So that's the value, I think, of that analogy.
Okay, so in terms of Corda, so Corda is a distributed ledger technology. So before distributed ledger technology, we have centralized service. So what we are moving from centralized service to distributed ledger technology. There's two things. So with centralized service, like a cloud service, so think of like Salesforce or the service you trust. So here's the two things that if you use cloud centralized service, you have to trust them, right? And so what is trust? So one thing is you have to believe they never get hacked. And the other thing is they never mark up. So that's the trust means. Like for example, so I have a wife and I have a kids. So I trust her. So she never cheat me, right? She never get hacked by someone else, right? And I give a generous amount of pocket money every month. I believe she never mark up, right? So, but one day she came in, and so I asked her, so can you do this? If you want me to do this, you need to pay more, right? But I've been logged in, right? I've been logged in, so I can't switch. Of course, I can't switch the service. So the same thing, right? The same thing is going on. So if you use centralized cloud service, you have to trust, but it's pretty difficult to switch. But with distributed ledger technology, with Corda, then if you're not comfortable with the service, then you can switch another application. So that will give you the option. So that's the value proposition of Corda.
Nicely done. I think that was an excellent answer by all of our panelists for the value proposition of public versus private blockchains. Are there other questions? Sure.
Yeah, I'm most interested in global remittances, particularly going very, very long distances from industrialized countries into the developing world. And behind that, here it gets into the same value proposition, because you're going through, you've got legal issues there, and you've got a lot of organizations there, and there's going to be a trust on both sides, on the person who is sending the money and the person who is receiving the money. Obviously, there's going to be organizations there, and no one wants the cryptocurrency. They want their local currency. So you've got to get it out of a local currency into a cryptocurrency, have it remitted a long distance, and then have it from the other end out of the cryptocurrency back into the local currency as soon as possible. Now you've got all these legal issues there, of course there's a value there. Where is that today? How easy is that today, and how trustworthy is that today? That's my first question. I've got another one after that, but carry on with that.
Oh boy. Okay. So we'll start with the first question, and I think this is a great one. So our bank, for example, is located in the Philippines. In the Philippines, it depends on remittances, right? And a lot of remittances are increasingly in Bitcoin, particularly because people are not banked. And if you have a population that's not banked, you can use Bitcoin or other virtual currencies in a way that you don't need a bank for that. So it's actually great for that kind of stuff. But who wants to take this question?
And is that global or just in the Philippines?
It's global.
So yeah, I think currently, and you asked about the current state of things, most of the global remittances on the blockchain are on public blockchains, right? So Bitcoin or Ethereum primarily, but then there's also specific remittance blockchains. There's one called Ripple, which some large banks are already using to do remittances. I think some of the features of that, and Alyssa alluded to this as well, is the low cost of the transaction, right? So if I go to Western Union or I send a SWIFT transaction through my local Japanese bank abroad, it might cost me $40 or 4,000 yen and take a couple of days. With Bitcoin or Ethereum, it is seconds to minutes, and it's about 19 yen. It doesn't matter if I'm sending $100 or $100 million. The transaction fee is the same, and the time for the transaction to complete is the same. So that's the actual mechanics of the transaction itself. On either end of that, and you pointed this out as well, you need to have a local exchange, a cryptocurrency to fiat currency exchange. And some countries like the Philippines are fairly developed. Japan is quite developed as well after the FSA rule change this year in April or May, which essentially legitimized cryptocurrency in Japan. So both parties would need to sign up to a cryptocurrency exchange, assuming they didn't want to spend or hold the cryptocurrency itself. And obviously, there's risk in that, both in terms of the extreme volatility of cryptocurrency, as well as longer term and tax obligations and things like that. So in Japan, it's fairly straightforward. You go to one of the exchanges here on their website, you sign up and take an ID selfie and send them your documentation, and they send you a postcard, and within a few days, you've got a cryptocurrency account, and you furikomi them money, you send them money, and they credit cryptocurrency to your account, and then you can do whatever you want with that, right? On the other end of it, in other countries, most of them these days have know your customer, anti-money laundering process. They may ask for your local ID or your tax information. It depends on the country, but I would say that even in countries that don't completely have the rules figured out yet, that entrepreneurs have seen the potential of operating a cryptocurrency exchange and being the first mover there. So I would say most countries, if you have access to the internet and computer or a smartphone, you can take advantage of that. So the one level above that would be kind of the more complex, like let's link a bill of lading to the actual remittance and that kind of trade finance, and there's a lot of work going on there. But today that's sort of the state of the state.
Thank you.
You don't do crypto, so you don't get to answer. Other questions? Okay, back here. Speak loudly.
I have a question in regards to two questions. One is ICO. Now people like spending money, collecting money in second for like $1 million. But how realistic is the ICO is? The token gonna happen, or just they have bump or something, they have incredible sales. But I'm wondering how realistic that these projects gonna actually happen. And the second question is, I think Bitcoin's transaction fee and mining for electricity is tremendous right now. So yesterday I met Roger Bar. He said Bitcoin Cash is going to be a solution for that. Or other people try to solve this problem as DApps and IOTA. How do you think about these things? That's in my mind. I don't know. I want to have some answer.
All right, I think we all want answers. So we've got questions about the legitimacy of ICOs and if Bitcoin Cash is the solution. Okay. You guys want to try? Public blockchain.
I'll try to answer the first half of the question, are ICOs legitimate part. I think there's a broad spectrum of legitimacy right now. There are certainly some well-intended projects that are using it to fund the development of a platform that's going to hopefully help people. For instance, Ethereum, the platform we're working with, started with an ICO. Right now it's so popular and so easy to raise money quickly that a lot of dubious propositions are out there right now, and that it would be very risky to invest in them with an expectation that it's going to be a long-term success. I think a lot of the activity right now is that there's a limited supply of these tokens. It's exciting, and so even if you're putting money in initially, you may see a return on the value just because of the demand for this token, but as a project, a lot of them probably won't amount to something. I mean, the same thing happens in traditional businesses and ventures, and that's why we have regulatory bodies and governments who try to make sure that people don't get defrauded. Right now, there's a big clash right now of the way that ICOs have been facilitated. It's a big free-for-all right now, and the governments are trying to get on top of that to protect people from getting burned.
Do you want to do that one, or the costs of Bitcoin to Bitcoin Cash? Okay. Stick on your first question.
So I like stock trading, and I think that the ICOs are very similar to an IPO, right? So you've got a startup company, right? Do you want to bet your money on that startup company? You want to bet your money on that ICO, right? I think it's very similar. You've got IPOs that get into the marketplace and double, triple, whatever, right, in a month or two, right? And a lot of people make good money with that. Then you've got other IPOs of companies that crash very quickly, and some of them turn out to be fraudulent, totally dissolved, and everybody loses all the money. I think it's very, very similar to that. And my personal opinion is I would approach them the same way. Make sure you do your research and understand who's backing that ICO or that stock, that IPO. It's very similar.
Okay. Nobody wants to take the second question? Cost of Bitcoin mining?
So I think that everybody realizes that mining, right, which is essentially trading electricity for cryptocurrency, right? And that's why there's a large number of miners in regions of the world, parts of China or Iceland, where electricity is very, very cheap, because you buy a lot of servers with or customized hardware up front, but then you need to run that with this electricity over time. And the figure is something like $3 billion a year in electricity is being spent to mine Bitcoin and Ethereum. The second point around that is that unlike a standard currency where you've got a central bank or a consortium sort of arbitrating how this is all going to work, kind of the magic and power of public blockchains is that it's completely decentralized. And so to make a change, you need to get most people on board. And it's not 50% plus one, it's closer to 90 or 95% so that you don't cause a big split, right? And we saw that recently in the case of Bitcoin with Bitcoin and Bitcoin Cash. And that's a reminder that these are as much technology solutions as they are groups of people coming together to solve like a societal problem. And so the point there is that the public blockchains today are using proof of work because that's the best thing. And I think everybody recognizes it's not efficient, it's not very green in terms of energy usage. And so some blockchains are going to have more success than others in moving beyond that. And Ethereum, for example, is at some point in the near future, let's say within the next year or two, planning to move to something called proof of stake. And that has to do with, instead of solving these complex mathematical problems, if you commit the Ethereum that you hold, the ETH that you hold, to the security of the network, so essentially you lock it up for a period of time. Essentially the network pays you a fee on that, right? So you guarantee the transactions, and the transactions you guarantee, that you build into a block and run the code on, and everybody else checks the running of your transaction on that, and it's okay. then you get paid, basically, and that rotates around in a random sense on the network. That's the high level view on what that is. And so the idea there is that essentially it's way more efficient. It will allow even faster transactions. The block time in Ethereum right now is 12 seconds. In Bitcoin, it's about 10 minutes. But I think, so that's coming, right? And that will definitely help things. But I think on the other end, like that's a problem that private blockchains are very well positioned to solve, because they recognize that sometimes you've got a group of people that trust each other, organizations that trust each other, and have decided to solve that in a different way that's not proof of work. So that's a good segue maybe to one of the other panelists, Monet or Jeff.
I don't think they're going to talk about it.
Or no, maybe not. How they have
Well, I can just quickly talk about it. What you said, Jeff. So, in the Hyperledger world in general, you don't have this proof of work actually, or even proof of stake, right? So you don't have that electricity cost, what you call it, right? So it's back again. Sorry to use it again, but back to my Facebook Messenger analogy, right? I mean, how much electricity does it cost you to use Facebook Messenger? It's roughly the same, right? So that's the difference.
So can you relate to the other point regarding the transaction cost impact of this? She was
Maybe could someone repeat the question about the transaction cost?
You had the question about obviously the predictability of transaction costs depending on public versus private, and especially with Bitcoin prices changing, you suddenly had the explosion of transaction costs, and the stability of transaction costs could be quite essential for certain activities.
Sure. So I think we should let one of them answer this question in more detail. I think we'll get at what you're getting at. But at least in the private world, there generally isn't going to be a specific transaction cost for these transactions. Everybody is hosting their own copy of it, and they pay for that themselves. As every company, back to my iPad analogy, Apple and Online and FedEx, right? They all have their own computer systems. They're paying for it. It's the same in the private world in general that I work with. But in the public world, obviously, it's different.
So in Corda world, so we don't have a proof of concept, so we don't need electricity. So instead, what we do is what we call is the flow. It's like a flow. So think of emails. When we don't think of email. So with Corda, when we reach consensus between other parties, like we send a message and then sign the transaction and get it back to me, and sign the transaction and send to notaries and sign the transaction, and then it's done, right? So it's like exchanging emails. Right? So in terms of transaction costs, it's I don't think it doesn't take a lot. It's like a email exchange.
I would just make a quick note on the transaction costs, that it's I think it's a marketplace like anything else, that if you want to use the platform to transfer money, if you're using it to exchange Bitcoin, if it's cheaper to do it on the Bitcoin network than it is to change it back into yen and then use your bank to transfer it, you'll do that. You can make it consistent by using a closed platform that has a fixed price, but if that's more expensive than the public or whatever you choose alternative, then you may choose the public one.
Just to add one additional point. So in terms of actual dollars and cents or yen, right? So Ethereum or Bitcoin, about 19 yen for a transaction. I think Bitcoin Cash is something like a yen for a transaction. If you're operating a private blockchain, I expect it would be fractions of a yen or a cent for one transaction, assuming that you're doing millions of transactions a day on a single server, right? And so it's orders of magnitude different, right? So, there are some applications that today you can only really effectively run on a private blockchain, right? And then it has in the short term kind of limited or focused the utility of public blockchains to transferring money, because I don't mind paying 19 yen if I'm buying a cup of coffee or if I'm sending $10,000 overseas. And I don't mind spending 19 yen if I'm running an ICO and raising $200 million in 5 hours, right? But if I'm going to build an application on the blockchain and every time I insert a log entry or every time I do a calculation, I get charged 19 yen. That's just not going to work. And I think that public blockchains will see the applications that they're useful for change over time. And I think there will also always be a place for private blockchains just based on the cost aspect of it.
Okay, go to the question over here.
Yeah, I was surprised you didn't pick up a picture, the story on the supply chain. When we take a look at supply chain, you're moving goods and financing for those goods. And so you can look at it as two different parts there. When you have a small private group, you don't have to worry about the trust issue because you've got a club environment where the people that participated in the board and vetted, that's why they're on board. It's basically a system of record that you're sharing. Instead of everybody having an Excel spreadsheet that are different and then having to be updated and reconciled, you've got a single Excel spreadsheet that you're handing across to each other, right?
Yeah, that's correct.
That's about it.
And everybody agrees on the format.
Is there a question?
I mean, we're talking about it's nothing more than that.
Well, you're saying is it an analogous to the Excel spreadsheet, right?
You know, it's funny because I was trying to point out myself in a way was basically a private blockchain is just a database. You can use a Google spreadsheet and call it private blockchain.
It's a ledger.
And so what I try to enforce is what is the real core value of blockchain. You could say a blockchain is a shared database, but what's different about a public blockchain is that really it's immutable. Nobody can change it, nobody can erase it, not a government, not a bank, not somebody who's upset. So I think basically what he's pointing out is similar to what I was pointing out, is that private blockchain is really just a spreadsheet that's shared. And so him and I both are kind of wondering, like, where's the value proposition there?
Yeah, so, I mean, the spreadsheet analogy is actually pretty good. So how is it different from a spreadsheet or a database to that question, right? So one is it's encrypted, right? Maybe the reason encryption, right? One is it's fault tolerant too. It's got a fault tolerant mechanism built into it, right? So if everybody has their own copy of the spreadsheet, right? What happens if one person has one bit on their disk drive go bad? And then that changes the spreadsheet, right? So now there's a fault in one person's copy of the spreadsheet. How are you going to deal with that? Well, the blockchain and the Hyperledger has a solution for that, to resolve that. Right? And so you can always trust that that copy you have is fault tolerant and it's encrypted, so it's hard for others to access. And that adds a lot of value in terms of whether you can trust what you have.
Let them answer first.
My question to you is, how are you different from Swift? We've got a network for peer-to-peer in the financial services industry, and they do reconciliation of both sides of transactions. I don't see what the difference is there for you.
So if you share a spreadsheet with your colleague, then that's fine. So you trust your colleague, right? So you trust him or her. They never update the records without your permission. But if you want to transact distrusting party, I mean the outside of your company, then it's pretty hard to share one spreadsheet, right? Because they may just change the number of the amount of money, right? So with DLT or blockchain, so it's maybe possible to ensure immutability. So immutability means that you can't change the data, or if you change data, the other party will find you very easily. So I think that's a powerful position.
I know I'm the moderator, I'm not supposed to answer anything, but since we do trade finance, I just wanted to answer the Swift thing. So with Swift, right, banks will need to message each other, and they have to go through the centralized Swift network. right? So with blockchain, you don't need to go through the SWIFT network. This is similar to what Monet was presenting, right? Where you can contact directly between the banks and be confident that that is the correct information, it's in the correct fields that you need, that kind of stuff. Okay, so you wanted to make a point as well?
Sure. Thanks. Yeah, I had a couple quick notes on it. One on the trust aspect, that trust isn't necessarily binary. I trust this person or I don't. There's a continuum there. So you may trust the other party to have the right intentions or good intentions, but not necessarily trust their record keeping or ability to avoid mistakes. And then the other point on why you would use a blockchain or something else instead of a database. A database is designed to be quite centralized. You can build in the fault tolerances, you can add cryptographic signatures to make sure that one party has done something without any confusion there. And that's what a lot of the DLT technology is. You're taking the features that people found valuable in the blockchain space and adding it onto something that's more traditional like a database and allowing it to be, let's say, deployed in a way that is more distributed. So if I ran a copy of Oracle database in my institution and I want the other party to have that, well, it doesn't necessarily make sense to have a replicated copy on their end. So the blockchain and related technologies have found ways to solve that kind of paradigm.
Other questions? All right, let's go here first.
So it's more of a question regarding public blockchains, but I guess for you guys, you've chosen to go for Ethereum. I guess based on the fact it has the smart contracts. I'd love to hear your opinion based on, perhaps down the line, do you think there's any chance that a blockchain such as Bitcoin can adopt that kind of technology and features? And as a company that has chosen to use Ethereum, what do you think other companies might do in that situation?
So yeah, I mean, we were initially interested in Ethereum and smart contracts, and I actually excited by this, got interested in it by this event called the DAO, which is kind of the original ICO, a complete failure because it got hacked in some respects, but we saw the potential of it there. And I think that that if Bitcoin is sort of version 1 of blockchain and extremely successful and still very relevant, right, in many ways more relevant than Ethereum, Ethereum is kind of version 2.0 with smart contracts. I think that there's probably going to be a version 3 and a version 4, right? And we're seeing some different takes on public blockchains, things like IOTA, and I know that they representative from IOTA spoke at this forum recently as well. Focused on IoT, right? Small devices that can't do proof of work, and proof of work doesn't even have, even proof of stake doesn't even really have a place in the system, right? I think that any company that's looking at what technology they should pick today should try and, like any other company, identify their target market and what their customers might be interested in, but be prepared for the rapid pace of change in this space. I mean, really rapid. The documentation is the code at this point, and I think that's also made it very hard for many companies to really get a grasp on a lot of the public blockchain technologies, and I think some of the value in the private blockchains is that there is that support in terms of documentation and training and things like that. So, does that answer your question?
Yeah, I mean, do you think it's more likely to come from an upgrade in existing blockchains or more from new emerging blockchains?
I think it's going to be both, and I think the challenge for existing blockchains is overcoming the kind of momentum that they have and bringing their communities together, because any upgrade in the protocol requires, as I mentioned earlier, a significant portion of the people participating in it to agree to it, right? And we've seen the challenges of that with Bitcoin, and there's certainly been challenges in the Ethereum space as well. And I think that in that way, it's likely that disruption could come from a new player in the future.
Question over here, and then we're running short on time, so we'll take this question. Do then we'll see if there's any last few questions, and we'll, okay, everybody, it's too late now that I have this, and then we'll finish up.
Okay, well, then I'm happy, very well. I can relate to what you said, that it's difficult to grasp the development and the technology going on. So allow me to ask you to give me orientation on 3 application scenarios, and you tell me which technology you would use for each 3 cases and for which reason. So I work in a consumer finance company, and we produce cars and trucks, and we sell it across the country, and we finance them. And I'm into financing now. So scenario 1, to sell a vehicle and to securitize the financing behind. So stripping one, a leasing or a loan deal into small pieces and crowdfunding it. Scenario 2, within the company we have dealer networks. So before the car or whatever reaches the end customer, there are many transactions between headquarters, between dealer, and how to do those transactions within a highly trusted environment, so to say. And the third one is we also sell like to huge customers, like to 100 heavy-duty trucks to Cambodia, where we need additional trust. So we first get the money and then start the shipment. For these 3 transaction styles, which technology would you use for which reason? For which reason, please?
Okay, so this is a question about which blockchain technology or whether or not you should be using blockchain for this.
Oh, interesting aspect, yeah.
I did not mean to complicate that. That's not my fault. Okay, so does anybody want to take a stab at this? You want to?
So can I ask about scenario 2? So it's a transaction it's like making a contract or just sharing information?
Before we sell to a Japanese end customer, we first sell to Yanase the asset.
So you have the contract between.
Yes.
Okay, then. So if you want to make a contract, it must be very confidential, right? You don't want to share everyone, right? That contract, right? So then I think Corda fits to the scenario, because with Corda, so you don't have to share your contract information with somebody else, right? You just share the data between 2 parties, and then you get finality. So I think,
Why don't you put that on the blockchain at all? We've already got contracts in the filing cabinet. Once they've signed, they're legal. Who needs to put that on why do you have to put that on the blockchain at all? He's got a single counterparty. Yanase, one of the largest corporations in Japan, they one-on-one contract. Even if they go through those contracts, they can do that on paper. I don't see why we're using blockchain technology just to get this stuff with a contract.
Sorry, you're asking
why do you involve blockchain at all in that, especially just because he's got a contract with a counterparty?
And I think, if you want to
So with the paper, right, you've got a paper file, a paper contract, you've got a physical signature on there, it has to be shipped via courier, it's going to take some time for that to happen, that guy's got to sign it, right, you got to make sure it's correct. Then it's going to go back probably to the original person who signed it because they want to have a copy, and then also the other side needs to have their own copy, right? And then let's say you deliver the truck, and everything seems to go fine, right? Well, what if in the final delivery there's a problem with the transaction and you not only pay what's spent? Okay, so then you got to go back to the contract and check, okay, how much money was supposed to pay? Well, what if somebody took their copy of the contract and changed the 0 to an 8? Just wrote a little line on a piece of paper and did that, right? So the blockchain would help eliminate all the querying and moving the paper back and forth. You can do electronic signature, so that can be done in a microsecond as opposed to you got to get it to the right person who has the authority to sign it, get them to physically sign it, which eliminates that process. And then everybody's got an encrypted and trusted copy of the contract, which is virtually, back to the immutable point, impossible to change, right? So you can't just draw a little line in 0 and change it to an 8. So it solves all of those problems. That's how blockchain is.
Do you have Yanase doing that a lot? Like changing the 8s to 3s
There has been some accounting fraud in the world.
Yeah, but you can also use the DocuSign blockchain today, right? Like DocuSign has a blockchain, it's digital contracts.
Right, and I think this actually gets to the other question. It's not just, which technology do you use? It's, is this, do we need blockchain for everything? And there's some things where it's useful, and there's some places where we just definitely don't need it, right? And I think that the speakers could maybe speak to that question a little bit better than I could, which is, when would this be a helpful technology to use? So I'm gonna steal the floor and I'm gonna let them answer that question because we're out of time. So let me pose that question to you guys, and then I'll ask you guys to give a final statement.
Okay, so you might be able to guess my answer. My answer to the question is, when do you want to use blockchain? It's when you have a lot of different parties involved. The more parties you have involved, the more value there is to the blockchain in general, because it's not easy to keep, let's say, everybody in this room all coordinated, right? So, but if you have the blockchain, back to my planning the trip analogy, what if my family had 100 people in a reunion instead of only 5 of us? Well, then it's getting really complicated to plan this trip and all the logistics around it. It's really nice to have one central place where that exists. Everybody trusts it. It's easy to use. Everybody has the same way that they use it. It's kind of like an industry standard, right? So you can see the value of having that own in one place.
Stand up a website so everybody can access it.
All right.
Stand up a website so everybody can get access to it.
And in fact, in a lot of the blockchains we've implemented, there are websites that can access them. It's 24 hours.
So let me introduce how to start your new journey with Corda. So we have a website which is Corda.net. So please visit Corda.net and you will find intro white papers and technical white papers, and you can join Slack channel. You will find Stack Overflow, which is so where you can post any questions, and our developers in London, so who actually develop Corda, they will directly answer your questions. And you can also download from GitHub the Corda open source. So if you're a developer, please get your hands dirty with the actual code. And so if you're interested in Corda, please reach out to me. So after this conference, and finally we are hiring. So yeah, so please visit r3.net/job or something like that.
In the securitization of auto loans concept, I think something like a public blockchain like Ethereum that will let you expose it to a wide variety of people, but you're still going to have the same concerns about the legality and regulations about that. So you're going to want to make sure that that's legitimate for your country's laws and the let's say investors' laws, whether or not you do it on a blockchain or not. The other examples, you really need to know more about it to decide what technology to use. If it's one partner, one contract, yeah, you could write it on a piece of paper and be done with it. If it's more complex, there may be advantages to using some different technologies. And on the broader use a blockchain or not question, the gentleman in the rear made a good point that if it's something that you want, that you want to make sure it can't be suppressed, then a public blockchain is a pretty good use case for that.
So I think maybe just to build on that and some of the themes we talked about. We talked about transaction cost and speed, and talked about the unbanked, banking the unbanked, and remittances and securities and ICOs and things like that. I think that blockchain as a general technology or distributed ledger technology, started as kind of the spark of genius with Bitcoin and Satoshi Nakamoto, right? But it's moved through this spectrum since then, and similarly on the, let's say, the private distributed ledger technology, it's kind of moved through this spectrum of this is a database, and now hold on, there's some interesting things that have been proven in the real world, right? And then, to pull an analogy, right? I mean, we've had drones for 30 years, but we used to call them RC helicopters, remote controlled helicopters, right? And now somebody had the idea, well, hey, the the sensor technology, the processing technology is smart enough. Now we can have them hover there by themselves, right? I think similarly with blockchain, it's an evolution, right? And there's a lot of marketing, just talk out there about what it is or what it isn't. I think that it's up to each organization or individual to decide, like, does this really make sense or not? I would say though that one kind of innovation, right? And we say, well, why don't we just use a database? These parties trust each other already, right? I mean, banks, for example, financial institutions have thousands and thousands of people in their back offices still today picking up the phone and calling their counterparties when a transaction doesn't work from one database to another, and then they're emailing spreadsheets and well, could we just build a better database? And I think the answer is yes, we could. And that database may have some features of a blockchain, like every transaction is signed, right? And many databases today, many standard databases already have that functionality, and it's not just necessarily being used. And I think that some of the value of blockchain is people understanding that, hey, there's some value to us actually implementing these features and using these features. And I think, moreover, there's a technology called stored procedures, which is essentially running code inside of databases today. And that's kind of what a smart contract is on the blockchain, right? But people hadn't thought about it in the same way that we'll limit the smart contract to being able to do these certain things in certain ways. And so I think that the marketing and the hype around blockchain is going to be beneficial to all of these kinds of endeavors, and in the case of banks sending money overseas, we'll probably be able to optimize that cost a lot and hopefully pass it on to their customers in one way or another. Certainly will in the sense of market economics. And so I think that that's also a kind of a benefit of all this.
All right, well, thank you to our speakers, and thank you everybody for your questions. I know there's a lot more questions left. Our speakers are going to stick around so you can have bilateral conversations or arguments with them as well today, right now. We'll be sharing the presentations, right? Okay, great. We will be sending them out or posting them somewhere, so they will all be available to you. So if you'll join me in thanking our speakers.